In this tutorial, I'm going to give an introduction to multimedia as a subject. Now, before starting the tutorial, I will like to mention one thing that this subject is mostly theoretical. So it will be better if you go through the notes that I'm going to provide carefully. I think that will be sufficient for your study purpose. Now let's start. What is multimedia? Multimedia means that computer information which can be represented through audio, video, animation in addition to traditional media. For example, text, graphics, or drawing, or images. In other words, multimedia means where you develop a content by adding different types of media objects. Now come to the general definition of multimedia. Multimedia is the field which is concerned with computer-controlled integration of text, graphics, drawing, still and moving images, animation, audio, and any other media where every type of information can be represented, stored, transmitted, and processed digitally. Now, from these definitions, you can clearly infer what a multimedia application is. A multimedia application is an application which uses a collection of multiple media sources. That means in a single application, you will have multiple types of media sources embedded, such as text, graphics, images, sound, audio, animation, or video. Now come to hypertext. Hypertext, as a computer science or information technology student, you all know in a clear way. Hypertext transfer protocol is something which we are well aware of. Hypertext is a text which contains links to other text. The term was invented by someone called Ted Nelson. Now, if you look into a particular website, you will find that in the text contents, there are links for other websites available or embedded. And that is the main property of hypertext, a text which contains links to other text. And via those links, actually, hypertext navigation takes place. Traversal through pages of hypertext is therefore usually non-linear. Why non-linear? Because there is not any particular order available for the navigation among different pages. Now come to hypermedia. Hypermedia is something which is not constrained to be text-based. It can include other medias, for example, graphics, images, and especially the continuous media, sound and video. That means it is a kind of multimedia entity where graphics, images, videos, etc. can be clickable. And by clicking those contents, you can navigate to some other object. So in this diagram, you can see uh, how a hypermedia object can be organized. Example of hypermedia applications can be World Wide Web, PowerPoint, Acrobat, and many others. If you carefully observe these things, you can find that there are basically more than one kind of media available, and such as graphics, images, sound, video, etc. Now, what are the applications of multimedia? The applications for multimedia can be World Wide Web, multimedia authoring such as Adobe, hypermedia courseware, video on demand, interactive TV, computer games, virtual reality, digital video editing and production system, multimedia database system. I believe that you know these terms quite well. So I think we should not spend much time here. Now, multimedia systems. A multimedia system is a system capable of processing multimedia data and applications. A multimedia system is characterized by the processing, storage, generation, manipulation, and rendition of multimedia information. Now, characteristics of a multimedia system can be multimedia system must be computer controlled. That is the main characteristic of a multimedia system. Multimedia systems are integrated. The information they handle must be represented digitally, and the interface to final presentation of media is usually interactive. Now, what challenges you might face while developing a multimedia system? First one is distributed network. Now, in the present era, distributed networks are heavily in use. So, transport and sharing of multimedia contents sometimes might depend on your internet bandwidth or some other things. So, distributed networks can be a challenge for multimedia system. Then temporal relationship between data. Now, what I mean by temporal relationship, it is more related to synchronization thing. Suppose you are watching a video. So what will happen if the graphical content and the audio content are not synchronized? You can clearly imagine that you will simply laugh to that video. So temporal relationship between data, which means render different data at the same time continuously, is a challenge. And sequencing within the media, that means playing frames in correct order or time frame in video, is also a challenge. Here is the example which I have discussed before some time. Video and audio, where lip synchronization is clearly important for humans to watch playback of video and audio and even animation and audio. Ever tried watching an out of lip sync film for a long time? You will be bored within a few moments. Now, key issues for multimedia systems. The key issues multimedia systems need to deal with here are how to represent and store temporal information. Temporal information we have discussed here. How to strictly maintain the temporal relationship on playback retrieval. What processes are involved in the above? Data has to be represented digitally. That means if you have some kind of analog data, then analog to digital conversion and subsequently sampling is also important and an issue which you have to handle when you will deal with multimedia systems. And large data requires bandwidth and storage. For example, when you browse a particular website, there might be only text data. So several kilobytes of memory might be necessary. And network speed or bandwidth might not have to be much higher. But when you stream some YouTube video, then you need obviously higher bandwidth and storage. So YouTube videos are an example of multimedia content, which is, I mean to say, widely available nowadays. So, and those videos require large data. Hence, sometimes, not always, data compression might be mandatory when you will want to transfer your content over low bandwidth. Now, desirable features for multimedia system. Some of the desirable features for a multimedia system might be very high processing power needed to deal with large data processing and real-time delivery of media. It is really obvious if you observe the contents nowadays we deal in multimedia systems. You need really high processing power. Now, you need multimedia capable file system. Why? Because you need to deliver real-time media such as video audio streaming. Then special hardware or software might be needed. And you need data representation system. That means file formats that support multimedia should be easy to handle. Then you need efficient and high input output. Input and output to the file subsystem needs to be efficient and fast. Needs to allow for real-time recording as well as playback of data. Direct to this recording system is an example. Then you might need special operating system to allow access to file systems and process data efficiently and quickly. Then storage and memory is another feature which is necessary when you deal with multimedia systems. Then network support. Then you need relevant software tools which will be required to develop, store, and deliver multimedia contents. Now, components of multimedia system. So, what are the components you actually need while developing a multimedia system? You need capture devices, examples, video camera, video recorder, audio microphone, keyboard, etc. etc. Then you need storage devices to store the recorded content, such as hard disk, CD-ROMs, DVD-ROMs, etc. When you need communication networks, it might be over the local networks, it might be over intranets, or it might be through internet. You need computer system, multimedia, desktop machines, workstations. Now, if you look into the computer industry nowadays, you can find that GPUs are widely popular because they are uh, built in such a way so that they can handle heavy multimedia contents of nowadays. Then you need display devices. Display devices means the devices through which you will deliver the multimedia contents, such as if you want to deliver audio content, then you need high quality speakers. Then you need high resolution speakers, monitors, sorry, not speakers. Then you might need color printers, etc. Now, here are some of the applications of multimedia: World Wide Web, hypermedia, video conferencing, video on demand, interactive TV, groupware. For example, when we do our classes through Google Classroom, that is also an application of multimedia system, which is quite popular due to this pandemic situation nowadays. So let me have a brief look at multimedia data. So input formats, not out, yes, input and format, text and static data. So source of text and static data might be keyboard, speech input, optical character recognition, and then these input characters are stored character by character. So storage of text is usually done by 1 byte per character. That means when you type down a character, say C, you have pressed the C key in the text processor of your computer, then the C will require 1 byte to be stored into the system. Then you need a format for the data, such as HTML, rich text format, etc. etc. Now, Text and static data might not be temporal. That means time synchronization might not be necessary always. And size not significant with respect to other multimedia content. If you compare the size of text with other multimedia content such as audio video, you can find that text data requires less amount of size to be stored. When come to the graphics, it is another type of multimedia content and format can be composed of primitive objects such as lines, polygons, circles, curves, and arcs. And input are usually generated by a graphics editor program such as Adobe Illustrator when you have Blender nowadays. Graphics are usually editable or revisable, unlike images. Um, yes, they can be mathematically manipulated. Now, graphics input devices can be keyboards for text and cursor control, mouse, etc. When graphics standard, there are some graphics standards available in the market, such as OpenGL. OpenGL is the most popular graphics standard which is available nowadays. The graphics files usually store the primitive assembly. If you look at the project file, not the final output, you can see that those project files are usually stored in the format of primitive graphic contents which we have assembled in your project. For example, say you have generated your animation using lines, curves, circles, etc. etc. When you explore the project file, you can find those primitive contents there. Now, do not take up a very high storage overhead. Now, animations do not take up a very high storage overhead usually. Images are still pictures which are represented as bitmap. Input, obviously, the images are scanned or pictures are directly taken using digital camera. Input may also be generated by programs similar to graphics or animation programs. Stored storage. In terms of storage, 1 bit per pixel for black and white, then 8 bit per pixel for grayscale, and 24 bits per pixel for true color. Size. Now, size can be from megabytes, from a single megabyte to several megabytes. You know that the size of an image when you store a picture in your computer can be from kilobytes to megabytes. Compression is commonly applied. Now, if you look at the bitmap image format, it is uncompressed. That's why bitmap images have higher size compared to JPEG images, which is the compressed version. Now come to audio. Audio signals are continuous analog signals, input microphones, and then digitized and stored. Now, CD quality audio requires 16-bit sampling at 44 kHz. Now, the size requirement is usually higher. 1 minute of mono CD quality audio requires 5 megabytes. 1 minute of stereo CD quality audio requires 10 megabytes. Now, audio can be compressed such as in MP3 or FLAC formats. Now, come to video. Input might be analog video cameras and then they can be digitized. The video captured through analog camera can be digitized to store in the storage system. Now, there are a variety of analog and digital video formats available in the market. Raw video can be regarded as being a series of single images. There can be 25, 30, or 50 frames per second. That means 25, 30, or 50 images are played in front of your eyes within a second, which gives you an illusion that the contents are moving. Now, this is a kind of video format which actually our television system, PAL, has alternating lines. Uh, the television video format in India uses this video format. Then there is high definition DVD video format, and the size is quite huge. You can see that the size is 112 megabyte approximately for a minute to store uncompressed. Now, the size requirement generally gives rise to a consequence, which is digital video clearly needs to be compressed for most times. So that was the introduction to multimedia.